Hey, what's up guys? This week we're covering 4.1 and 4.2. 4.1 should be fairly similar since we've already covered radicals to some extent in section 1 in chapter 1. So now we're just going to go over a little bit more on what we can do with radicals or square roots or cube roots. So here are a couple questions for you to follow. So in A, B, C, and D, it's asking us to do an operation. So first one is square roots and addition. So what it's asking us is if we take the square root of 36 and add the square root of 64, will it be the same thing as the square root of 36 plus 64? So, and then can we generalize that to just using general numbers such as a and b? Okay, so, well, first of all, let's go ahead and give this a shot. So, let's take the square root of 36. Well, the square root of 36 is equal to, if you have your calculator, you can do that, but if you know it just off the top of your head, you should know that this is equal to 6. So the square root of 64 is equal to 8. Okay, so let's try this out. So let's see. Let's do the square root of 36 plus the square root of 64. Well, that's the same thing as we just solved as 6 plus 8, which is equal to 14. Okay, so is that the same thing as the square root of 36 plus 64? So let's try this out. So let's add 36 and 64. So 36 plus 64. That's equal to 100. So this is equal to the square root of 100. So what's the square root of 100? That's equal to 10. So you can see here that we got 14 and 10 right here. So the square root of 36 plus the square root of 64 is equal to 14, and that does not equal the square root of 36 plus 64. Okay? So these are not equivalent. So we're going to make an assumption, and we're going to say that this generalization, if we were to take the square root of a plus the square root of b, we can say that this does not equal the square root of a plus b. Okay? And we know that this is not true because we have an example right here. We just proved it wrong with an example. Well, let's go to b. So this time we're using multiplication and not addition. Okay? So is the square root of 4 times the square root of 9 equal to the square root of 4 times 9? Basically, what we're trying to prove is square root of a times the square root of b equal to the square root of a times b? Are these equivalent? So let's go ahead and give it a shot. We'll see if this example works out. So the square root of 4 we know is equal to 2. The square root of 9 is equal to 3. Okay, so let's try this out. The square root of 4 times the square root of 9 is therefore equal to 2 times by 3, which is equal to 6. Okay, now let's try this side right here. So the square root of 4 times by 9. So what is 4 times by 9? That's 36, so that's equal to, what is the square root of 36? And that's equal to 6. So we see here that the square root of 4 times the square root of 9 is equal to 6, which is equal to the square root of 4 times by 9. So we're going to assume that this generalization right here, that this is correct. Yes, it does. The square root of a times the square root of b is equal to the square root of a times by b. Okay, now let's try using the same thing but with subtraction. Okay, so is the square root of we're going to say a is the square root of a minus the square root of b the same thing as the square root of a minus b? Are they the same thing? So we have the square root of 64. We know that that's equal to 8. We have the square root of 36. We know that's equal to 6. So the square root of 64 minus the square root of 36, that's equal to 8 minus 6, and that's equal to 2. So let's do the square root of 64 minus 36. So what is 64 minus 36? That's equal to 28. And what's the square root of 28? That's equal to 5.292. So obviously that square root of 64 minus square root of 36 does not equal the square root of 64 minus 36. Therefore, our statement up here is false. So the square root of a minus the square root of b does not equal the square root of a minus b. And we know that's not true because we have an example to prove it. Alright, so let's try this last one. This time we're using division. So the square root of 100 is equal to 10. The square root of 4 is equal to 2. Okay, so the square root of 100 divided by the square root of 4 is equivalent to 10 divided by 2, which is equal to 5. So is that the same thing as the square root of 100? Sorry. The square root of 100 divided by 4, that's equal to the square root. 100 divided by 4 is 25. And the square root of 25 is 5. So we know that the square root of a divided by the square root of b, we'll assume that this is the same as the square root of a divided by b. That these will be the same. So what does this tell us? How can we generalize this? We can basically assume that if we have plus or minus, that these, anytime you have a plus or minus, that you can't assume that these will be equal to each other. In fact, we just proved that they are not the same. However, what we can assume, what we use using examples, is that the square root of a times by the square root of b is the same thing as the square root of a times by b, and then the same thing here. The square root of a divided by the square root of b is equivalent to the square root of a divided by b. So these are their properties for this. So whenever using multiplication, this is called the product property of square roots, where it says the square root of a product equals the product of the square roots of the factors. So using this, let's try and simplify. We can use this to simplify it. So we have the square root of 108. Now can we simplify this? So can we break 108 into factors? So let's think about it. What can we divide 108 by? Can we divide that by, let's say, 4? So we can. So this is equal to 4 times 27. So knowing that, we know by this rule up here that this is equivalent to the square root of 4 times the square root of 27. And the square root of 4 is equal to 2. So we have 2 times the square root of 27. Can we simplify that anymore? Well, the square root of 27, well, I know that I can break that up to be the square root of 9 times by 3. Okay? So this is equivalent to 2 times the square root of 9 times the square root of 3. And the square root of 9 is equal to 3. So times by 3 times by the square root of 3 and this is equal to 6 square root of 3. So basically, I just took the square root of 108 and I simplified it to be 6 square root of 3. So I can't reduce that any further because I can't take the square root of 3 and have it be a whole number. So let's try that with this right here. This time we have a variable. So we have the square root of 9 times x cubed. So according to the property that we just talked about, this is the same thing as the square root of 9 times the square root of x cubed. Square root of 9 is 3. And the thing is about the square root of x cubed, this is the same thing as the square root of x squared times by x. So this is equal to 3 times the square root of x squared times by the square root of x. Now, radicals like this will undo an exponent. So this is equal to 3x square root of x, if we were to simplify that all the way. And there you go. So we just use the product property of square roots to simplify these terms. Now using division is just called the quotient property. And it's basically just says the same thing, but with division. So we have the square root of 15 divided by 64. So by this property up here, I know that this is equivalent to the square root of 15 divided by the square root of 64. The square root of 15, can that be broken down into anything further than that? I don't think it can. It would just equal, nope, I don't think we can simplify the square root of 15. Can we simplify the square root of 64, and we know that that is equivalent to 8. So this is equal to the square root of 15 divided by 8. Now let's go to B. So again, using the property up here, I know that this is equivalent to square root of 81 divided by the square root of x squared. Square root of 81 is equal to 9. Square root of x squared is equal to x. And there you go. Another way of looking at this, let's say up here, you could say that this is the square root of 15 and this is the square root of 8 times by 8. Now, this is a square root, which means it's to the root of n equals 2. Sorry, one second. That should be 8 times 8. Basically, if there's anything underneath your radical, under a square root at radical with 2, that means we can take out one of them. So this is equal to square root of 15 divided by, since I can take out 1/8, that means these are both gone. That's just one way of looking at it, but you don't have to look at it that way. In any case, so we're just basically just simplifying. So can we use the same properties but with cubed roots? So square roots mean that it has a root of n power of 2. Cubed root has a nth root of a power of a root 3. So this is a cubed root, this is a square root. Just oftentimes with square roots we don't write the number there. So cubed root. So can we simplify this right here? Okay, so we have a cubed root of negative 128. So basically what we're trying to think is there a number multiplied by itself 3 times that equals 128? So can we simplify this? So the cubed root of, let's see, 128, is there a number that we can find multiplied by itself 3 times. That will give us 128. I'm not sure if there is, but let's see if we can break it down and simplify it. So we can divide 128. Can we divide that by 2? And divide that by 2. So 128 divided by 2 is equal to 64. So we can say that this is 2 times by 2 times by, let's say, 32. So 2 times 2. Let's see, 32 divided by 2 then is equal to 16. So we can do this 2 times 2 times 2. 2 times 2 times 2 times 16 is equal to 128. And 16 can be divided by 8 by 2. So that's 2 to the 5th power, to the 6th power, to the 7th power, I think. Yeah. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, okay? So look at what we just did right there. Basically, we can sum this up to be the cubed root of 2 times 2, 2 times 2 times 2 times 2 times 2 times 2 times 2. One of these has to be negative, by the way, because we have a negative sign right there. Okay? So basically what we can do, see how we have a group of 3 here and a group of 3 right there? So that means we can take out 2 2. So this is equivalent to 2 times 2 times the cubed root of negative 2. And that's equal to 4 times the cubed root of negative 2. Just like that. So that's how we can simplify it, is that we can break this down into as many factors as we can and try and find groups of 3. Okay? And it's okay to have a cubed root with a negative number in there. It's not okay to have a square root with a negative number, but it's okay to have a cubed root with a negative number. Okay, let's see if we can do the same thing for b. So can we break down 125 and x to the 7th? So we know that this is the same thing as 125 times by the cubed root of x to the 7th. So 125 is the same thing as 5 cubed. So this is equal to the cubed root of 5 times by 5 times by 5 times by the square root of x times x times x. Basically, what we could do is say that this is equal to x cubed times x cubed times x, because this right here is equal to x to the 7th power. So this, we know, will be 5, because there's a group of 3 right there. So 5 times by, now this is the same thing as the cubed root of x cubed times the cubed root of x cubed times the cubed root of x. That's equal to 5 times by, this will be x, and this will be x, and this will remain x cubed, or the cubed root of x. So we can reduce this to be 5x squared times the cubed root of x. So basically we can use properties of cubed roots almost exactly the same as properties of square roots. Now the rest of this will basically just be for your own practice and demonstration, except do not do anything 17, 18, 19, or 20. Don't worry about doing any of those. But the rest of these are just for your practice. Notice that 5 through 12, that 5 through 8 are all square roots, 9 through 12 are cubed roots, and then 13, 14, 15 are square roots, and 16 has a cubed root. Okay, so that should be everything for 4.1, and make sure that you also watch 4.2 for this week as well.